Welcome back to C++ discussions. Today I am starting with a small questions. Question number 1. Here I have one small program. I have a small program for adding two numbers. Now you can see one function here. There are lots of local variables inside this function. Now we know that whenever this control is hitting this close bracket, all the local variables memories are getting deallocated. How this is getting deallocated? That is the question number 1. Now there is three local variables inside the main. These local variables memories are getting allocated and deallocated during runtime. And the memory which is allocated inside the stack memory segment. Who is responsible for memory allocation and deallocation? That is the question number 2. After end of this session, you will be capable to answer both questions. So, I am going to explain with a small program. I am going to write another program. Now, I have a small program. There is a main. Inside main, I am writing int I. Next line I am writing I which is equal to 10. I have one more line for this program. Int j which is equal to 20. This is my program, very small program. I am going to write the equivalent assembly program for this small program. Now we have to discuss something about some special purpose register. There are some special purpose registers which is present inside the processor, and the special purpose registers are, one is stack pointer, second one is base pointer, and other one is program counter. Stack pointer is nothing but which is pointing to the current stack frame, and it's a variable pointer. I will explain more clearly. Assume stack frame of this function is starting with a particular address. So whenever it's need to allocate the memory, stack pointer which will grow in reverse direction or downward direction. Now the assembly equivalent of this program will be int I. Assume I'm going to draw. This is my assembly program which is available in the text memory segment. Int I. So we have to reserve a memory for this integer variable. Size of this integer variable is 4 bytes in 32-byte microprocessor. Now it have an address portion and there is instructions. Int I, so stack pointer has to move down to a 4 byte. Here, assume this address is 1000. Subtract size of this integer from the stack pointer. Size of the integer is 4 byte in 32-bit microprocessor from stack pointer. Now this I got memory. Here, assume stack pointer is somewhere. It is moving down 4 byte for this integer I. Now I am writing I which is equal to 10. This 10 has to move into the location where we allocate the memory. So next instruction will be move 10 to stack pointer where the stack pointer is pointing currently. Again I have one more memory allocation, that is int j. Again 4 more byte we have to allocate for this j. Assume this is available inside another address. Again subtract 4 from new stack pointer. Now currently stack pointer is pointing to some different location. Again subtract 4. Now assign this 20 to the j. Again we have to do move 20 to where the stack pointer is pointing now. This is available inside the text to memory segment. Now we have processor will start reading one by one. This is our microprocessor. These are the instructions to the microprocessor. Processor will start reading these instructions one by one. There are one more special purpose register. Its name is program counter. Program counter, I am calling it as PC. This program counter have the address of the next instruction supposed to execute. Processor will start reading this line. So program counter have the address of the next instruction. You understand it? Processor is starting executing line by line, but this program counter is holding the address of the next instruction supposed to execute. Assume stack is starting with an address 7000. I am just making an assumption. Stack frame is starting with an address 7000. Now we can try to draw the stack frame of this program. Here I am drawing the stack frame of this program. This is the stack memory segment. First one, stack is starting with, or stack pointer is currently pointing to 7000. Made an assumption. Now subtract 4 from stack pointer for the memory allocation of this I. It was 7000 before. Now subtracting 4 for the variable I. Now this will be 6996. Now next line. Now processor is reading this line. So move 10 to where the stack pointer is currently pointing. So 10, which is moved now, stack pointer is pointing to some new location. Again processor is reading this line. Subtract 4 from where the stack pointer is pointing. This is for J. Now stack pointer is pointing here. Again subtracting 4 by 6, 9, 9. How much it will be? 2. Now stack pointer is pointing to this location. Now next instruction, move 20 to the stack pointer where currently pointing. So it will be 20 is moved over here. This is what is happening internally. Now whenever compiler is hitting this bracket, here what will happen is add 8 to the stack pointer. This instruction will be generated. 8 is the sum of the local variables inside this function. So it will be at 1000 for the location. Add 8 to the stack pointer. So whenever control is hitting this close bracket, stack pointer is getting added with sum of the all local variables present inside this function. So here it will, what will happen? Here where stack pointer is pointing now, 6992, it is pointing. We are adding 8. So again this memory is going back to its initial location. This is the way it is, memory is getting deallocated. You understand it? Now we understood like there is a stack pointer. It's a variable reference. It is keep on moving inside this function. Initially it was at 7000. Then whenever you are allocating the memory, it's going down. Again you are allocating the memory, it's going down. Again you allocate memory, it will keep on vary inside this function. So that there is another special purpose register also available inside the function, that is known as base pointer or frame pointer. Frame pointer, I am calling it as BP. BP is a static reference which will be same throughout the function execution. So here BP also will start from 7000, or which is a static value, but stack pointer will keep on decrement or keep on change, but base pointer will always constant throughout a function. You understood? Now we have so much special purpose register. One is stack pointer. Stack pointer will keep on decrement whenever we are allocating a memory. Stack pointer is responsible for memory allocation and deallocation. Then there is one more special purpose register, that is program counter. Program counter is holding address of the next instruction supposed to execute. There are one static reference to the stack frame, that is base pointer. The value of the base pointer will be same throughout the function execution. Now whenever control is hitting the close bracket, the sum of the local variable which is getting added with the stack pointer, so stack pointer will go back to its initial location. This is all about today's discussion. Next class we will discuss about how the function call is working inside a function. Hope you are understanding the session. If ever you have any doubts or any questions, you can comment down. Thank you for watching this channel.